Okay, so we're moving on to look at question 3 here. Okay. If we noticed in that last question too, stem and leaf plot was handy to be able to look at that data. Um, and it did preserve all the numbers. Okay, looking at it, we were able to see each of the individual numbers, but they're still kind of clumped together. Remember, we said the data was all clumped towards the center. So it might be a better picture if we try to group it differently. Okay, so in this case, we're kind of looking at the alternative to the bar graph we mentioned earlier called the histogram. And it's a picture, okay, to kind of represent what we're going to see here. So basically, we're breaking the data down into some categories. Now, if you take statistics in the future, you might see the reasoning behind why we broke down the categories the way we did. Your elementary students are probably not going to have to be making that decision. But again, a histogram is something that you would have to read in the future as an educator about data. So we took that data that we just put on the stem and leaf plot, and we went through and we counted how many of the individual values fell into these intervals. Okay, there is one value that falls in the 30 to 35, one in the 36 to 41, one in the 42 to 47, three in the 48 to 53, six in the 54 to 59, four in the 60 to 65, four in the 66 to 71, two in the 72 to 77, two in 78 to 83, and two in 84 to 89. Okay. If you look at this, these heights actually represent the frequencies that we saw these categories happen. So we have 1, 1, 1 in the first three, 3 in that 48 to 53 category, and so forth. The heights would represent the number of results we saw within those intervals. Okay, so just by looking, not looking at the data, but just looking at the histogram, what is the minimum time estimate or the maximum time estimate? In terms of trying to answer these questions, it's a little bit hard to do. Okay, um, we can't really tell you what the minimum time estimate is because all we would know is just what this category is. We would know we had one measurement somewhere between 30 and 35. We wouldn't know exactly what it is. If we went to try to do the maximum time, we would know we had two estimates somewhere between 84 and 89, but we wouldn't know exactly what it was. Okay, so it would be next to impossible without some additional information to answer those first two questions. How many estimates were in the interval from 42 to 53? Now, that is something we could answer. We know that there are one from 42 to 47, and we know that there are three from 48 to 53. So there must be four altogether between those two. How many people guessed 52? We wouldn't know that here. All we would know is that there were three guesses somewhere between 48 and 53, but we wouldn't know what any of them were just by looking at this graph. Okay, so again, a histogram is really good to show us the frequency of a particular interval of responses, but they don't retain that individual information like a stem and leaf plot were. All of these questions I would be able to answer, these very specific questions, if I had a stem and leaf plot, not if I had a histogram. Okay, so stem and leaf plots are best used when I need to see the individual results. Bar graphs and histograms are best used when I just need to know how often something is happening. Okay, so it's a little bit different there. Why were people's estimates typically too long or too short? And explain your thinking. From the histogram, we can only tell that there were about 12 pieces of data below 60 and about 10 in groups above 60. It doesn't really tell us about those people in the 60 to 65, okay? So it looks like we're kind of split almost in half. Again, it's hard to make very specific statements from here because we can't see the individual values. Okay. What's a typical value for this time estimate? If we go on down here and we're trying to answer that in part C, the individual data is lost. Okay, remember we can't see the individual results if all we're looking at is the histogram. So we really can't say what specific estimate. All we can say is that we know that somewhere in this group, okay, which is that 54 to 59 group because it's 6 tall, we know that this was the group that people typically responded in. So we might, if we're trying to say a typical value, we might say somewhere between 54 and 59 based on this result. Okay, just because that's where the majority of the results were. Again, we could not call out a specific number because that's lost when we create a histogram or sometimes in a bar chart, depending on how we create it. Sorry. To ask us, how do we describe the shape of the data in the histogram? Okay, this histogram starts to look a little more symmetric. Okay, we do still see the majority of the data is clustered near the center, but it's looking a little bit more symmetric. If we were to draw that curve, imagine me taking a pen and just drawing a line to kind of follow the edges here. It looks just a little bit more symmetric than what the stem and leaf plot did. Um, we don't see any obvious skew here. We don't see a longer tail necessarily on either side. It's still clustered in the center. It's not perfectly symmetric, but more so than the stem and leaf. Okay. One question often gets asked about histograms. Since the bars do touch, students are often confused about how they break up the numbers for these intervals. If I were labeling these, we would start out with this one as 30 to 35, the next one with 36 to 41. Okay, we don't want to share end labels. We wouldn't want to call this 30 to 35 and then this one 35 to 41 because you have a result of 35 that could technically belong in two groups. The trick to labeling this is to always let the boundary between the bars be one decimal place more specific than the results you get. Okay, so now let's think about that. These results were all in whole seconds, right? So what I might say is that this bar or this boundary here between the two bars is 35 and a half. Okay, I know I don't have any results that are going to be half because they're all in whole seconds. So that clearly makes a boundary that puts my 35 seconds down here and my 36 seconds up here. If I had numbers that results that were counted in tenths, then I might make my bar go to the hundredths place. Okay, so I set these boundaries up to be one decimal place more specific than the results that I have, so it clearly sorts all of my results into one category or another.